Hello everybody, my name is Dakota Lowrance. I am a MMET major. My advisor is Dr. Scott Wagner, and for the last 2 semesters I have been working on an Aqueous washer tank. So the sponsor for this project is Selke Fabricators LLC out of Baraga, Michigan. And they're a small business, and they always look ways to expand upon their business. And in a small competitive area such as the Kiowa, staying out against competition is key for the vitality of one's business. And the way that Sucking can do this is to wash their own machine parts. Now let's go on to the problem statement. For this project, I want to help Selke design a washer tank for industrial hydraulic cylinders that are used for heavy equipment. This design must include a heating element to heat up the water and soap solution and evaporate the water to eradicate the leftover oil and dirty mixture from cleaning the cylinders. Additionally, the design includes a pump that will be used to bring the water soap solution from the tank to being sprayed on the cylinders. Lastly, the design will need a separate control panel to control all the devices, as well as an emergency shutdown option. The successful implementation of the design will allow Selke to acquire additional assets and grow their business. Now, unfortunately, I don't have a cost analysis yet, since the quarantine has made it hard to finish this presentation, but I will try my best. What we're looking for is under $2,000, and that's what the competition would cost, and it can go from $2,000 to $100,000 to even $1 million part washer. So my customer does not want to spend that much money, so doing it in-house with their skills is very idealistic. So here's a final design that has been modeled, and that they would be, before the quarantine happened, that they would be working on and be finished by the time that Expo came around. So what you see here is a full tank. It's 17 foot by 3 foot by 4 foot. The top plate here on top would carry 200-pound cylinders. That is a machine full of oil and some dirt and from the process, and some soot from wells all around it and what have you. And you have 2 workers on either side of this tank that have nozzle, that have hoses, and they can go all down 17 foot on each side and spray it down and clean them. And at the end, it would be picked up probably either by a human if they're within the 50-pound weight limit. Sometimes they are, sometimes they aren't, or they can use machinery to pick them up. So let's dig deeper into this tank. So on the top, you have these handles that on the darker blue towards the end that lift up where the wire would be. This tank's mostly hollow, except for the small section at the end above or below that cover, so that debris doesn't get into it. And that tank's around 70 gallons. In the front is a incomplete control panel. This one I showed without the door. This would be waterproof, since we're dealing with water. And underneath you have 4 pockets in pump and filter with piping. And here's what it looks like. The same left to right. On the left, you see the hollowed body, and underneath you would have a lattice of structures to support the top so it doesn't deflect downwards. You have a mock of a filter that will go there, along with 2 pipe splitters for each of the hoses that would be able to reach to the end to spray off the cylinders. You have legs, so it's at working height. You have 4 pockets that are off-center for the center mass, so they can balance easier when it's lifted up and transported. It doesn't have to be a monument in a industrial setting. And then on the right, you have a mock-up of the pump that the customer wants and has, with appropriate piping to connect all of it. And then here's just a close-up of that. Also, additionally, on top is a offset. That's a quarter inch offset, so that a cover can be inlaid when it's not in operation. since the shop does not operate 24 hours a day, so that debris can't get in there or anything like that. For the technical specs, again, it's 17 foot long by 3 foot wide by 4 foot high. Currently, the model, we have it at 1,200 pounds, but that's likely to change. It could be heavier due to additional supports and so on. Ideal flow rates around 5 to 10 gallons per minute. And the current, if you fill the tank all the way up, it'd be 70 gallons in that small area towards the control panel side. That is very extreme. I think idealistically it'd be around 50 gallons. So you have some space, so it doesn't splash all over the place when it's in operation. And then you have the filter, which is pretty decent, almost 13 inches tall and about 4.5 inches in diameter. This filter is unique because the water solution is going to get hot around 170 degrees, so it needs to handle that. And also the filter quality, which is very high, which is 5 to 10 microns. So then you can just keep reusing the same water, and at the end of the week, then you can, whether the filter hasn't filtered out and that's backed up in the tank, you can just scoop out the sludge. There's also a drain plug there that can be made. Currently, it's about, I think, like 1 inch in or 2 inches in diameter. That can be made bigger. We're going to get rid of it altogether if it's not doing anything. The pump that we have currently is very old, and a lot of the markings actually have eroded away, even from the faceplate. That's 3/4 horse, 40 pounds, 3/4 inch inlet outlet, 120 volts of power. But what is unknown, because the faceplate has kind of eroded, is that there's no PSI in gallons per minute. So that needs to be tested and verified to make sure that we hit that 5 to 10 gallon a minute mark. And then for the heating element, it's kind of like the one that's like in your basement for your hot water heater. This is idealistic for 70 gallons, even though 50 is going to be used, but they can also be adjusted with the control panel. That's 240 volt and 350 watts. Or, I'm sorry, 3,500 watts, excuse me. The important thing, over time here, is design for safety. That's a big proponent of this project. All the power accessories are down the bottom, so they can't be knocked over or shut off, or it can get burnt or anything, except for spraying the water. Even that's 160 degrees tops. The hoses are the back end, so that reduces tripping. The control panel again is waterproof. Emergency shut off that you can easily get to. It's a simple latch. It's not going to be a key. It's just going to be a panel you pull. There's going to be no sharp corners. They're going to be bended or grinded, and there's removable cover that also keep things safe. And then lastly, with the addition of the manufactured Aqueous washing tank and integrated design for safety, Selk Fabricators LLC has the ability to gain additional assets with minimal to no workplace injuries. Lastly, as we make 2 quick acknowledgments, I want to thank my advisor, Dr. Scott Wagner, for putting up with me for the last 2 semesters. And being a one-man group is difficult, and without him, I probably wouldn't be able to be here doing this today. And I also want to thank Selke's GM, Nick Lindemann, for all his communication help in allowing me to do this and come in and solve a problem that they have. Thank you very much. Have a wonderful day.